CoDeF introduced a novel content deformation field that creates a canonical content representation of video while separately modeling temporal deformation. Yeah, dear friends, by leveraging AI's understanding of human shape, poses and texture, this method bridges the gap between virtual avatars and real-world physics focused only on short-term object deformation. The SceNeRFlow builds a canonical model of a scene and maps all deformation to it, ensuring stable tracking even in complex motion. Yes, dear friends, this method represents a significant advancement in AI-powered character modeling, virtual try-on applications, and metaverse avatars, making high-quality 3D reconstructions more accessible than ever before. Happy morning, dear friends. Here's yours, Dr. Ajay. Welcome to Demystify with Ajay. Dear friends, today we explore how cutting-edge techniques are revolutionizing video processing, avatar creation, and high-fidelity image restoration. Dear friends, imagine AI seamlessly tracking complex motion in videos, creating relatability digital humans from simple videos, or restoring facial details with an almost magical touch. From ensuring temporal consistency in video processing to constructing 3D clothed human from a single image, AI is transforming how we interact with visual content. Okay, join us. We uncover how these innovations are shaping the future of AI-driven media. And dear friends, you can find the full paper link in the description. If you reference these papers in your research, make sure to cite it. Okay, let's dive into the first content. It is under video analysis and understanding. Okay, the first paper is CoDeF, C-O-D-E-F. So content deformation fields for temporally consistent video processing. Dear friends, traditional video processing often struggles with maintaining consistency across frames, leading to flickering effects and distortions when applying AI-driven enhancement. Here, this CoDeF introduced a novel content deformation field that creates a canonical content representation of video while separately modeling temporal deformation. By doing so, this CoDeF enables AI-powered video-to-video translation and tracking without additional training. Imagine editing a single frame of a video. This CoDeF ensures that these edits naturally propagate across the entire sequence while maintaining coherence. And dear friends, this techniques also enables non-rigid object tracking, allowing AI to track even complex elements like flowing water or moving smoke by bridging the gap between image and video processing. Of course, CoDeF brings us closer to flawless AI-enhanced video generation. Okay, the next paper, it is on Relightable and Animatable Neural Avatar from Sparse-View video. Dear friends, creating high-quality, relatable and animatable digital avatars has long been a challenge, requiring multi-camera setups and complex scanning process. This new method makes it possible to generate highly realistic neural avatar from just a few video frames or even a single video captured under unknown lighting condition. Unlike existing methods which can only reconstruct the surface geometry, this approach introduced hierarchical distance query, that is HDQ, a novel algorithm that efficiently estimates distance under arbitrary poses. It allows AI to accurately model lighting and reflection, making avatars look realistic in different environments. And of course, yeah, dear friends, by leveraging AI's understanding of human shape, poses and texture, this method bridges the gap between virtual avatars and real-world physics, opening door for hyper-realistic avatars in gaming, virtual reality and digital influencers. Okay, the next it is on image construction. The paper is RestoreFormer towards real world blind face restoration from undegraded key value pairs. Difference: restoring real world degraded facial image is a complex challenge, especially when AI struggles with fine details and conceptual consistency. This RestoreFormer introduces a fully spatial attention mechanism that enhances facial reconstruction by understanding contextual interactions within the image. Unlike a previous method that really on generic facial priors, RestoreFormer uses a reconstruction-oriented dictionary that stores diverse, high-quality facial details, improving its ability to recover lost texture and features. Additionally, the model incorporates an extended degradation model, allowing it to generalize beyond synthetic datasets to real-world, low-quality images. And yeah, dear friends, this innovation is a major leap forward for photo restoration, surveillance, image enhancement, and AI-generated face reconstructions with unparalleled fidelity. Next, it is text guided reconstruction of lifelike clothed humans. Difference: reconstructing a lifelike 3D human model from just a single image has always been a major challenge due to missing visual information, especially for the unseen back view. And here this tech addresses this by combining text prompts and personalized diffusion model to infer missing details and generate realistic, high-fidelity 3D clothed humans. By leveraging visual questions answering VAQ and garment praising models, this tech extracts fine details both about clothings, textures and styles, ensuring that the reconstructed humans look natural from every angle. And yes, dear friends, this method represents a significant advancement in AI-powered character modeling, virtual try-on applications, and metaverse avatars, making high-quality 3D reconstructions more accessible than ever before. Okay, next paper, it is on SceNeRFlow. You can just specify anything as like, but of course we have already discussed this. That is NERF. That is the exact function behind this. Okay, we just go into this paper. So, time consistent reconstruction of general dynamic scenes. Difference: capturing non-rigidly deforming objects in video such as people, animals or natural elements has traditionally been a difficult task due to the lack of long-term motion consistency. This SceNeRFlow, how come we can just specify? Yeah, SceNeRFlow or like that. So, introduce a dynamic neural radiance field. Yes, there is actually a NERF, there is neural radiance fields. We have already discussed in a few episodes before, that reconstructs object while preserving long-range temporal coherence. And yes, unlike previous methods that focus only on short-term object deformation, the SceNeRFlow builds a canonical model of a scene and maps all deformation to it, ensuring stable tracking even in complex motion. This breakthrough paves the way for realistic 3D video reconstruction, enhanced motion capture for VFX, and accurate scene digitization for AR/VR application. And dear friends, that concludes today's exploration of AI's latest advancement in video processing and image construction. From content deformation field that bring consistency to video AI to text guided 3D human reconstruction and state-of-art facial restoration, these innovations are transforming how AI understands and generates visual content. As AI continues to evolve, we are entering a new era where machines can track, restore, and even imagine visuals with incredible precision. Stay tuned for more deep dives into AI-driven vision. Don't forget to like, share, and subscribe to keep up with the latest developments. See you in the next episode, dear friends. Happy learning.